Welcome to this Salient pole synchronous machine lectures, and we have seen that in a Salient pole machine we generally don't try to draw an equivalent circuit where you can show terminal voltage, armature current and induced EMF EM in a single equivalent circuit. Because of the fact that the armature MMF can be anywhere in space depending upon at what power factor the machine is operating, and therefore, it is necessary to break up those currents in ID and IQ form. And then in case of synchronous machine, two reactances are of importance. One is XD, XQ and RA. Unlike a cylindrical or non-salient pole synchronous machine where only one reactance is sufficient, that is called synchronous reactance. Now, today first what I will do, we found out the power expression of a salient pole synchronous machine, considering it to be a generator mode. One can extend that to motor mode, all these things. But today first thing is, after learning all these things, let us try to recapitulate and advise you how to draw the Phasor diagram correctly, because that is at the heart of problem solving of salient pole synchronous machine. You must draw the Phasor diagram correctly. In case of cylindrical rotor machines, the drawing of Phasor diagram, what you only need to know is that what is the terminal voltage. Generally, terminal voltage will be known, armature current will be known and the power factor angle will be known. So, in case of cylindrical machine, there was only one reactance XS, and we told you that if this synchronous machine, which is non-salient pole type, then if it is a operating as a generator mode, you draw the circuit diagram like this, EF, then show the RA XS, and here is your V terminal voltage, and since it is operating as generator, draw the current like this. And then we found that EF is equal to V plus IA ZS, that is the synchronous impedance. So, it is better you start with V and this one. So, this is generator. In case of motor mode in non-salient pole machine, I told you it is like this, that is RA, this is ZS no doubt, and here is your V terminal voltage and here is your EF. But this time you show the current, it is motor. So, it is drawing power from the bus like this, and then we find that EF will be equal to V minus IA into ZS. What is ZS? ZS is RA plus JXS. Now, it is often, last time also perhaps I told you that addition of vectors is much more easier. I mean, human being love to add than to subtract. So, therefore, this equation also can be, same equation can be written as V is equal to EA plus IA ZS. So, in case of motor mode, it is better you first draw EF, then add to it the IA ZS drop to get the terminal voltage. So, this you must remember. I mean, this is no additional informations about machines, but this way if you do, you will be making least mistake, I mean no mistake perhaps. Now, suppose salient pole synchronous machine, I will apply the same rule, and I will now show you today that giving different condition, how to draw quickly the correct Phasor diagram. Suppose I say case 1, this I have drawn in some way, but let us see and follow me, try to follow me how this phasor diagram can be drawn rather quickly. Suppose I say it is generator mode, and it is leading power factor or lagging power factor it is operating. Let us first take lagging power factor and connect it to the bus V. So, how to draw it? Generator mode, remember EF will be always above, always leads V or above V by angle delta, no matter whether it is lagging or leading power factor, EF will be above V. Achha, now what you do first is that you just assume that let this be your q axis, this vertical line. Then the next step is, then d axis is fixed, this is d axis, this is q axis, these two axes get fixed. Now, in case of generator, EF addition wise if you go, it will be V plus the drops, is not, this will be the thing. Now, what I will do is this, therefore, EF must lie on this line. I do not know where it is now, but I am sure EF is always along q axis, this much I know, and I am considering lagging power factor. Therefore, the internal power factor angle psi will be also lagging, and I draw the armature current I A, suppose. This is my I A. Lagging EF also, of course, I do not know right now how much it is, but I know EF lies on q axis and it is lagging power factor. You want to draw phasor diagram. So, draw I A lagging, but I will not show this to be theta, this must be psi. Anyway, that I will write later, and once I get this, I can draw ID and IQ, which will be like this, is not. So, forget about IA now, leave with ID and IQ. Now, since it is lagging power factor, where VA is supposed to be, VA must be somewhere here, this is V suppose, and this is your theta, understand, this is V, this is theta. Then you know EF is equal to V plus, suppose RA is 0, I am drawing that case. It is possible to draw RA non-zero also, but let us first understand this. V plus J ID XD plus J IQ XQ. This will be my EF. Therefore, if this is V, this is lagging angle, then V plus J I D X D, ID is this way, J I D X D that way. So, it will be J I D X D plus J I Q X Q. So, did I made a mistake? So, this is q axis EF, lagging power factor IA. Okay. So, you get ID and IQ like this, then terminal voltage will be also lagging power factor. So, B, I made a mistake, it has become some 90 degree, that is why the mistake is. So, V will be here. This is V, is not, because it cannot go 90 degree, and this is theta, sir. This is theta. Therefore, armature current lagging power factor I have taken, by whatever angle it lags, I draw V here. Then to V I will add J I D X D, it is here J I D X D, and then, but I know E f will lie here, and you see I q is such that this is J I q x q, and this will be your E f. So, quickly I will once again redraw it, because it has become slightly clumsy. So, the argument is generator lagging power factor, it is operating at lagging power factor. So, what you do, first draw q axis, Once q axis is drawn, d axis gets fixed at 90 degree, draw that. Then I am saying it is lagging power factor. So, I A will be here. Okay. And I know E f will lie here, then V must be, because E f always leads V in case of generator mode, E f will be always ahead of V. Therefore, drawing of V this side, which I did for the first time, it is better, you also understand. V cannot be here, because generator mode tells me that V will be behind E f, understood. So, V must be here. Terminal voltage, that is the thing, and this will be your delta. Then this I A will have two components, that is I D and I Q. I Q, mind you, this is not I A, this is I A, this is I A, and then V plus J I D X D you draw, and this length will be higher because X D is higher. So, this is J I D X D, and then J I Q X Q, fine, J I Q X Q, and I will tell this is my E f. And you know, a lagging power factor, at lagging power factor, a generator is over excited, because E f is greater than the magnitude of V, everything is consistent. If you want to theta, theta will be this angle. Got the point? This is how generator lagging power factor I have drawn. Suppose once again I am telling, suppose I want to draw leading power factor, generator salient pole, generator leading power factor. So, once again what you do, you first draw q axis, suppose this is q axis, and this is suppose d axis. Q axis means finally your E f has to lie here. Now, I have been asked to draw phasor diagram for leading power factor. So, with respect to V, current must lead, and also with respect to E f, suppose current leads, that is the internal voltage. So, I first draw the I A here, I A. IA. Since it is generator, your E f will lie along this, V must be behind. So, I draw next V. This is your V. suppose this is V, and this angle is theta, power factor angle theta. Got? Since IA is this, so I will draw ID like this ID plus IQ are the two currents. And you know this angle is your psi, internal power factor angle between EF and IA. Of course, the position exact point where EF will be here, I am yet to get that. That how I will get? By using this relation EF is equal to V plus IARA I have neglected, but that can also be taken into account. ID J IDXD plus J IQ XQ. That is what I have to add to V. Addition rule I will apply to get EF. So, what will be the thing? V plus J IDXD. ID is here, J ID is will be there below. So, V plus J ID XD. IQ is along this, J IQ XQ will be 90 degree leading IQ. So, this plus this J IQ XQ, and then this will be your EF. Got the point? So, everything is in place. Generator leading power factor, see V is always behind EF, power factor angle is angle between V and IA, internal power factor angle is angle between EF and IA, EF is along this line and IA is here. So, this will be psi and this will be the phasor diagram when generator is supplying leading power factor. Note that the length of EF is much smaller compared to length of V. So, it is under excited. So, a under excited synchronous generator, no matter whether it is salient pole or non-salient pole, will be operating at leading power factor, under excited synchronous generator. Now, let us do the same thing for motor mode. So, let us assume that salient pole motor, all salient pole motor, okay. And in salient pole motor, first of all, because of reversal of direction of armature current, we know this is true. EF with RA equal to 0, I will be sketching first. EF will be equal to supply voltage minus the drops in case of motor. So, minus J ID XD minus J IQ XQ, that is the thing. Then I will convert it to this form, that V is equal to same equation EF, because I feel very much comfortable with this. Hopefully, you will also feel comfortable, otherwise this will also do anyway. So, J ID XT, because addition comes naturally to human being, I mean to us, I suppose so. So, this is like this, V is equal to EF plus J I D X T. Therefore, it is better in case of motor mode, you start with the EF, go on adding the drops to get terminal voltage. That is what I want to stress upon. Okay. Now, how to draw the phasor diagram? In case of motor mode, always remember V will be ahead of, or will be ahead means will lead, will be ahead or lead EF. That is the thing we have seen. Therefore, to draw the phasor diagram now, under what condition? Suppose lagging power factor, salient pole motor operating at lagging power factor. How it will look like? So, like the previous one, first draw the q axis. Let this will be the q axis. Then d axis is fixed. Draw that d axis. And I know EF will lie somewhere here. Suppose EF is this much. Okay, I will draw it like this. EF is suppose this much. And I have told you that lagging power factor. So, lagging power factor means current will be lagging both the terminal voltage as well as EF by some angle. So, I will then draw the armature current. This is because of lagging power factor, I draw it here. At the end, where do I expect V will lie? V will be ahead of EF, it must come here. If it has not come, then I have made a mistake, that is the idea. So, this is IA. So, first I find out its direct and quadrature axis component IQ. I find it out. Then I go to this equation, means this equation only I am applying, but in additive mode. That is why I have started with EF. Then to EF you have to add these drops. So, to EF you add J I d x d, that is this length will be this one J I d x d plus J I q x q, I q is here. So, J I q x q will be like this. So, J I q x q, and then this must be your V. This angle must be delta. Let us show the angles. This must be the power factor angle, angle between V and IA, lagging power factor theta, and this angle must be internal power factor angle psi, like this, and your phasor diagram is over. Now, I told you since V is the bus voltage, it is always better to take voltage on reference. Now, this phasor diagram, when I have started with EF, got this is the correct phasor diagram. Then you call this is to be your reference phasor. How does it matter? The V. Call this V to be V angle 0 degree, nothing like that. This phasor diagram remains same. But if you follow this rule, I personally believe you will very quickly and correctly draw the phasor diagram of a salient pole synchronous machine. First you ask yourself whether you are drawing the phasor diagram for a motor. Yes, in this case for a motor. If it is for a motor, V will be ahead of EF. So, you and always start with EF, go on adding the drops, that is the idea. So, EF is first drawn q axis, then where is armature current drawn? Oh, it is lagging power factor. So, IA will be placed behind EF, that I draw, and once I have assumed q axis to lie vertical, d axis must be along this line, then I A is there. So, I D, I Q are known. If I D, I Q are known, then you assume that suppose this is your E F at that time. So, 2 E F add j I D x d plus j I Q x q and get your V, and it is in right place, correct, absolutely correct. So, very quickly you can draw the Phasor diagram of salient pole machines. Let me tell you also, let me once again draw, and you see in case of motor mode E F is, and this angle is delta, E F is behind V, because direction of torque reverses, E F is behind V and all things are there. So, if some parameters of this, you can apply the properties of triangle, this that, to solve simple problems, apparently complex problem, but very quickly. Okay, armature current, power factor angle, these that are given, draw the Phasor diagram correctly, then you are through. See which sides are given, things like that. Achha, let me draw the Phasor diagram when the salient pole machine, and you see lagging power factor salient pole machine is under excited, because length of V, which decides the resultant field, is much higher than the excitation field, which is given by the length of E F, we have seen. Achha, now let us try to draw. I am salient pole synchronous motor operating at leading power factor, operating at leading power factor. I want to draw correctly the Phasor diagram, correctly and quickly, that is the thing. So, once again I will use this relationship V, I will start with E F, then end up with V by adding these drops j I d x d plus j I q x q, that is what we will be doing. Now, so these steps are same, draw the q axis first, this is your q axis, okay. Then d axis gets fixed, so this is your d axis, okay. E F will lie here, that is there. Now, leading power factor, so armature current leads Q. So, you first draw the, where will be V? V will be ahead of E, I know V will be here and current leads. So, you draw the current first. Suppose this is your armature current. If this is my armature current, then I know its D component is this way and Q component, let me, this is I Q and this is your I A, and this is the internal power factor angle psi. Now, suppose I say this is my E F, E F. So, to E F you add these two drops j I d x d. Now, I d is this way, j I d x d will be downwards, is not? I d is this way. So, j I d x d will be like this. So, minus to this you add and it will be along q axis, j I d x d will be there. Then you have to add plus j I q x q, I q is here and j I q x q will be in this way. So, j I q x q and this will be your V. This will be your theta and this will be your power factor angle, internal power factor angle psi. Where is delta? This is delta. So, this will be the salient pole synchronous motor operating at leading power factor. This will be the phasor diagram and you can quickly draw it. We will continue with this in the next class. Thank you.